Hello, Math 10 class. This is for March 23rd lesson. On this lesson, we're going to learn two sessions. First session is 4.1 exponential functions. Exponential function means the exponent is a variable. And this is b here is called a base. Okay, b, this is the base. That's why they use the b. And b cannot be 0. B cannot be 1. The reason, because if you're 0 to the x power, then what do you get? That's not exponent. Exponent means they will go up all of a sudden, they go down all of a sudden. If b equal to 1, again, 1 to the any power just 1. It's just a straight line. So we're only interested in two cases. One is when b is between 0 and 1, when b is greater than 1. If b is between 0 and 1, they will go down, and this is always a 1 here, okay? And for b is greater than 1, they go up, and this is also 1 here. And this is nice, called the asymptote. It means that the graph wouldn't go underneath. Okay, here also, this nice asymptote, the graph wouldn't go under here. And you also read the graph from left to right. Okay, so this is going down, and this is going up. And how do you graph these kind of functions? And look at problem number 30. Okay, and number 30 is that f of x, we're going to graph fx equal 10 to the negative x. 10 to the negative x, we are x, not negative x, so we need to convert first. We made this to be 10 to the negative 1 and then x. Well, 10 to the negative 1 is the same as 1 over 10 to the x. So that means that 1 over 10 is between 1 and 0. So that we are in this case. Okay, this is between 1 and 0. So therefore we case number 1. And the graph is going to coming down. Now how do I graph this? Just pick a couple points. Usually I pick negative 1, 0, and 1. Sometimes I pick 2 also, but sometimes I don't. But it kind of gives you an idea already. So I will do this one first when x equals 0. Anything to the 0 power is equal to 1 except 0 to the 0. We don't know what is it. But we don't worry about that right now. It won't happen because we have b cannot equal 0. And when x equals 1, this is 1 over 10. And when they're negative 1, you just flip this number. So it's a 10 over 1. So this is 10. Now we're going to graph. Okay, graph this one first. X equals 0, y equals 1. Right here. X equals negative 1, y is equal 10. Negative 1, 10. So let's say it's about approximate right here. Okay, 1 is 1 over 10. So a little bit, tiny bit. So the graph is going to be like this. Okay, so you can see it looks like this graph. So that's for number 30. And let's try the one. Let's try number 32. Number 32, we're going to graph g of x equal to 2x minus 3. So you can see the base is 2. So it's a b is greater than 1. So that's the case number 2, the one that increased. Okay. Now, how do I take care of this one? Okay. We're going to graph. So the first thing we're going to graph of y is equal to 2 to the x. And negative 3, that means you're going to shift the graph of 3 units to the right. Okay. And then you're going to shift the graph 3 units to the right. We use transformation of the graph. Transformation is pretty easy to use. You just need to get used to it. Okay. So we graph the basic first and then shift the graph of 3 units to the right. And when you see the numbers attached to the x, that usually means you move on the x direction. Okay, if you're seeing the number attached to the y, then you move up and down. So we're going to pick point for this one, for here. And we're going to do the same thing. pick the same 3 points. And when 0 to the 0's equal 1 to the first equal to 2. And this one is a reciprocal. So we're going to graph this one. And 0, 1 right here. 1 and 2 right here. And then negative 1 and 1/2. So write this. Okay. And then now we are not done yet. We're gonna shift the graph. Okay, we're gonna shift the graph with 3 units to the right. So this is just a number 1. So we graph number 1. Now we're gonna shift the graph. We use this point here. We go 1, 2, 3. And then now you're going to just look at it, eyeball it. Okay, so it's approximately like this. So that's number 2. Okay, so that's the graph. And then next chart 1, next chart number 38. Number 38. We're going to graph y equal to 3 subtract 10 to the x. X minus 1. This time, let's just write this. Okay, I'm going to move this in the first. And then plus 3. That was easier for me to look at it. First of all, this means that you're going to move 1 unit to the right again and 3 units up. But what this negative means, the negative in front here means a reflection. Okay, so this is a reflection right here. So we're going to, here's our step. So first we're going to graph the original one, okay, 10 to the x. Now we're going to do, the next thing we're going to do is we're going to do 1 unit to the right. 1 unit to the right. And then now we're going to do the reflection by x-axis. Okay, and number 4 step, we move with 3 units up. So that's our 4th step. So we're going to graph this one by picking points. So we pick the point, negative 1, 0, and 1. So when x equals 0, so 1, this is a 10, 1 over 10. Okay, so now we're going to graph this. So 0 and 1, you can see this right there, 1 and 10. So let's say this is a 10. I don't have enough room, so just put 10 here. And then negative 1 and 1 over 10. Because the 10 is bigger than 1, so you know the graph is going to go up. Okay, now we're going to move 1 unit to the right. Right here. Okay. And we're going to use the green, 1 unit to the right. Okay, so this is number 1, number 2. Now we're going to reflect by the x-axis. So when I reflect it, I'm going to use the purple. So I reflect this one down. Make sure you try to make it as close as possible. A little bit. So okay, you make sure this graph looks like just a flip over. You don't want to be different. Okay, you want to be same shape. And then I'm going to call this number 3. Now the last thing is I'm going to reflect. I'm going to move 3 units upward. So I take these points right here, right? I go 3 units. Okay, so this is 1, 2, 3. And now there's asymptote, move the asymptote also. Okay, so the asymptote, I'm going to use the blue. 1 more unit up. So this is my asymptote here. Because that way I don't go too much far. Then I'm going to. So that's my number 4. Okay, the red one is my number 4. So this is the x-axis move to here. Okay, That's the asymptote, so you can see they move. Asymptote move 1, 2, 3. So this is y is equal to 3. Okay, and that's how you graph this one. So this one has a few things, 4 things. The next thing is that we're going to do some problem, application problem related to exponential functions, okay? If you don't understand it, first, then watch the video a couple times until you get it, okay? That's one good thing about it. You can be watching it a couple times. Number 15.4. This time they said there's a certain species, okay, and there's certain mouse. There's a type of mouse live in the island. Initially, okay, the population is 30. Initially, there's 320 of them. And then they found out they double every year. Okay. And they said find the model. Okay. Find the model. Well, here's the model. Okay. For doubling, it's equal to initial. So let's say initial, I'm going to use give a name. So I'm going to give this one initial. Well, maybe I just put initial here. Okay. And then double, we use a 2. Year, we use a T. So that's the formula for doubling. Okay. Initial here, my initial, put it here. Double, put a 2, and then a T. Part B. They said estimate the mouse population after 8 years. They said y to the 8. Okay. If t is equal to 8, how much do you have? So you just go 320 to the 8 power. Okay, so that's all you need to do. We couldn't calculate with 2-bit here, just leave like that. So that's for number 15.4. The next application we're going to learn is called compound interest. Okay, interest compound has a few things. Okay, they can compound daily. That means 365 5 days. They can compound monthly, 10 months, quarterly, 4 quarter, and then a semi-year. Semi-yearly, that'll be 2 times, or yearly. And then just 1 time. Most of the time, the more time they compound, the more interest you get. Majority of the time, we usually see quarterly, okay? Very rare we see like daily. Unless it's your credit card bill, they do daily. The formula we're going to use, okay, they said A is equal to P1 plus KR and then KT. Oh, not KR, I'm sorry, RK. I think it's RK. 1 over R type divided by K. So what this stands for? A stands for the amount you get at the end of the year or at the end of time. So this is the initial amount. Okay. Ask for interest rate. Sorry about my writing. K stands for the number of times compound. per year, okay? And then your T just a time. T here just a time. How long you gonna leave your money in the bank? So let's see the example. Okay, here's the example number 16. They said if you have $4,000, so the initial you have $4,000 in the bank, and the interest rate you're paying, okay, your R is equal to 5.75%. The first thing you do is you convert to decimal, so move 2 decimal to the left, 0.0575. And they said compound quarterly, okay, quarterly. When they compound quarterly, so this is AR. Oh, QU, sorry. Compound quarterly. And that means that your case equal 4. They ask you how much money left in 4 years, okay? So I just do one of them, T equal to 4. I do part A only. The rest are just change the T. They say how much money you will get after 4 years. So I just put in the formula. So this is the money I will get. Your P is equal to 4,000. So that's your P. Okay, 4,000. Times by 1 plus your R is equal to 0.0575 divided by K is equal to 4, and then KT, so 4 times 4. So the first thing you should do using your calculator, I don't have a calculator at home, okay? If you use a calculator, you first multiply it together, make it to be 16, okay? Then you're going to take your calculator, okay? You go 0.0575 divide by 4, and then you go equal sign first, and then you add 1, okay? And then you go equal, and then you use the notation that your calculator have is a y to the x. If you don't have that notation, okay, I think they have this notation. They have this one, okay, like that. You can use this notation also, okay. And then you put in 16, and then you go, once you put in 16, they start something come up, and then you go multiply 4,000, and then you go equal, and you should get the answer out, okay? Your answer should be more than 4,000 because you get some interest, right? So that's basically for 4.1. Don't forget to come to the office hour tomorrow afternoon.